The universe is an endless ocean of stars, galaxies, and nebulae. For centuries we have looked up and wondered about the dots of light so far away. But today we can finally see what those dots truly are. We are no longer just guessing. We are discovering, and the worlds we are finding are stranger than our wildest dreams. They are planets that defy our understanding, worlds of impossible extremes, and places that force us to rewrite the very rules of the cosmos. This is the story of the strangest planets in the universe. We begin with a new world right in our own cosmic neighborhood. A super-Earth has been spotted. This planet, called 2I 715b, is about 1.5 times the size of Earth. It is also relatively close to us. In cosmic terms, a mere 137 light-years away. To put that into perspective, most of the exoplanets we find are hundreds of light-years distant. The spectacular cosmic phenomena we see, like black holes or nebula, are often thousands of light-years away. So the proximity of 2I 715b is a very big deal. But the most important question is, could it be habitable? The term habitable zone is an estimate, a cosmic guess of where a planet might have the right conditions for liquid water. It's a region at a specific distance from a star where temperatures on a planet's surface should be just right for water to remain liquid. This isn't a perfect science. The true conditions on a planet depend on many other factors, such as the type of star it orbits, the planet's own reflectivity, its size, and its atmosphere. In 2014, scientists created a stricter, more precise definition to find the very best candidates for life. It's called the conservative habitable zone. This zone is based on a planet's energy intake from its star compared to Earth's. If a rocky planet receives between 40 and 85% of the energy our planet does, it is considered to be in this zone. These worlds have a much higher chance of being habitable, and 2I 715b is right there. This super-Earth orbits a star known as an M-type star, also called a red dwarf. It's a star that is much smaller and cooler than our own Sun, but orbiting a red dwarf is a good thing. Red dwarfs live much longer than our yellow dwarf Sun, giving their planets more time to potentially form life. This specific red dwarf is older than our own star, and it has low magnetic activity, which means it's a calmer star that doesn't flare up like younger red dwarfs. Flares can be incredibly powerful and could potentially strip away a planet's atmosphere. Because these stars are where we are currently looking for planets that could support life, our super-Earth is an incredibly exciting find. 2I 715b is very close to its star, completing an entire orbit in just 19 days. Because the star is small and the planet is so close, the planet passing in front of its star happens frequently and is very clear to observe. This makes it easy for powerful telescopes, like the James Webb Space Telescope, to study its atmosphere. The James Webb is bringing us into a new era of understanding distant worlds, allowing us to detect the specific gases that make up the air on a planet millions of miles away. If it does have an atmosphere, that atmosphere might be easier to spot because it's a super-Earth. This could lead to even more hype because it would make 2I 715b look like a very good place for life to exist. But there's more. There might even be another planet in this system, also in the habitable zone. We're not sure if it's real yet. If it turns out to be real, it would be about the size of Earth and the smallest planet ever spotted in a habitable zone by the TESS telescope. Another cool thing about 2I 715b is that it may not just have water on it. It could be an entire water world. An ocean planet is a type of planet that has an ocean covering its entire surface, or even has subsurface oceans. They might not have much dry land because the water can cover everything. Sometimes, the entire planet can be covered in other liquids like lava or ammonia. For planets outside our solar system, we can't see surface water directly with our current technology. Instead, scientists look for water vapor in the atmosphere as a hint that there might be liquid water below. Our models show that planets with oceans might be pretty common in our galaxy, meaning there could be lots of ocean worlds out there waiting to be discovered. The most important part about Tau 715b is that it's in the so-called small planet radius gap. If you were to line up all the planets we've discovered from smallest to largest, there's a sudden noticeable gap in planets that are about 1.5 to 2 times bigger than ours. Scientists are fascinated by this gap because it tells us something about how planets form and change over time. It's not that planets don't form in this size range, they actually start off larger and then lose some of their mass, like a balloon gradually deflating. Perhaps it happens because of how they orbit to their stars, with the star's energy blowing away some of their mass. This gap holds a lot of mystery, and planets like our new super-Earth are clues that could help us unravel it. We aren't even sure if this gap exists around red dwarfs. Maybe it's a gap in how dense these planets are, rather than in their actual size. So studying our new planet is even more interesting, as it will help us learn more about distant stars and the worlds that orbit them. I mentioned TESS just a moment ago. NASA's Transiting Exoplanet Survey satellite has been in space for 6 years now, and has been incredibly successful. NASA launched TESS because we had already found over 5,000 planets orbiting other stars, mainly thanks to the Kepler telescope. But Kepler mostly found large planets, not necessarily like Earth, so we decided to focus TESS on finding smaller Earth-like planets around nearby, bright stars, making them easier to study with future telescopes. Here's how it works. The camera observes stars and looks for changes in their brightness. If the brightness suddenly drops for a while and then gets back to normal, it could mean there is a planet passing in front of it. TESS shows us the size and orbit of these planets. Then, ground telescopes help determine their mass. With these 3 parameters, we can figure out what the planets are made of, and if they're rocky like Earth or gassy like Jupiter. TESS has made some incredible discoveries. One example was the TOI 700 system, where it discovered its first ever Earth-like planet, TOI 700d. This exoplanet also orbited a red dwarf and is even closer to us, about 100 light-years away. Unfortunately, it's unlikely to be habitable because the temperatures there are too extreme. Another big discovery was made in the AU Microscopiae system. TESS discovered a planet about 4 times the size of Earth, and another nearly 3 times Earth's size. This system has become a key area for studying how stars and planets form and change over time. TESS has also spotted a variety of other exciting finds, and as it enters its 6th year, we can only expect more exciting discoveries to come. Strange structures aren't only found around distant stars. Sometimes they're right here in our own solar system. On Mars, for example, there are several faces. Back in 1976, when the Viking 1 orbiter was checking out the red planet, it spotted a big structure that looked like a human face in a region called Cydonia. A bit later, we also discovered the so-called crown face in the Libya-Montes region of Mars. Mars in general has a lot of strange structures on it. In 2022, we spotted a door-like structure there. NASA's Curiosity rover snapped some pictures of a rocky mound called East Cliffs on Mount Sharp. This mound has natural cracks in it, and one of them is about the size of a dog door, looking like something from an ancient Egyptian tomb. A lot of people hyped that story up, making the crack look bigger than it actually is. Some people think it's hinting at extraterrestrial life, but after looking closely, NASA found out that it was just a narrow crack in the rocky terrain. These cracks and gaps are pretty normal in rocky areas, both on Earth and Mars. The cracks form naturally over time, maybe from wind erosion or from Marsquakes. Mars is a goldmine of mysterious structures. Recently we found some strange spiral shapes there. These are giant coils made of lava, and they look like big springs or loops. For years, we weren't sure whether Martian valleys were formed by lava or by ice. These lava coils are shedding new light on that mystery. Thanks to higher resolution images from NASA's Mars Reconnaissance Orbiter, researchers have spotted 269 lava spirals that can't be explained by ice-related activities. These lava coils are like the ones we see on Earth, such as those formed by Hawaiian lava flows. They range from 16 to almost 100 feet wide and are subtle, blending into the dusty Martian landscape. These coils can teach us a lot about Mars's composition, especially its crust and mantle, about which we still don't know much. Mars isn't the only planet with strange structures on it. For example, Saturn, the gas giant of our solar system, has a fascinating feature at its north pole, a huge hexagon. This is a hexagon-shaped cloud pattern that is about 20,000 miles across, making it larger than the entire diameter of Earth. It's thought to be a jet stream of gases moving very fast, at about 200 miles per hour. This hexagon was first spotted by the Voyager mission in the 1980s, and later seen up close by the Cassini mission in 2006. The Cassini mission noticed a change in its color from a beautiful blue to a golden hue over time. There are different ideas about why Saturn has this. One theory suggests it forms because of the way winds move at different speeds near Saturn's poles. Similar shapes were created in lab experiments when liquids were rotated at different speeds. Another idea suggests that a slow-spinning stream of air, along with Saturn's special weather patterns, might be responsible. In 2020, we found that when storms are surrounded by winds swirling in the opposite direction, they can create a steady hexagon shape. So far, this is the most likely explanation. Saturn also got lucky with bizarre moons. One of them is called Iapetus. This moon has a very weird feature, a huge ridge that wraps around its middle like a giant belt. This basically makes it look like a giant walnut. This ridge is incredibly tall by our standards, around 8 to 12 miles high and stretching 124 miles wide. It covers more than 3/4 of the moon's surface and is considered the third largest mountain range in the entire solar system. We don't have a clue about how this enormous ridge formed. It's unlike anything seen on other planets or moons, but there is one idea: the ridge might be the remnants of a dead mini-moon. Billions of years ago, a colossal impact shattered chunks of material off Iapetus. These pieces circled around the moon, forming a mini-moon or a subsatellite. Over time, the gravitational pull of Iapetus tore this mini-moon apart, creating a ring of debris around it. As the debris from this ring fell back onto Iapetus, it built up the massive ridge we see today. They think this process happened quickly, maybe over centuries. Saturn's gravity didn't interfere because Iapetus was quite far away from it. We need more simulations to see if this theory is true. Titan, another one of Saturn's moons, also has some weird stuff going on. In its methane seas, scientists have spotted strange bright spots called magic islands that seem to pop up and disappear over time. We have no idea what they are. Titan's atmosphere is packed with complex organic molecules that clump together and fall to its surface like snow. These magic islands might be snow clumps that soak up methane and sink very slowly. But there's a problem in water. Molecules stick together, which is why things can float on top of it. But methane is different. It likes to grab onto other molecules, so it makes any solid thing sink immediately. Yet these magic islands don't sink. There's a theory that these islands might be like sponges made of ice with lots of holes. When pieces of this porous ice come loose from the edge of the lake, they can float on Titan's seas for a bit before going down under. There are also other ideas, like bubbles of nitrogen gas or waves caused by the wind. We need more research to know for sure. Moons like to be weird. Just look at our own. In 1971, we found a patch with missing soil on our moon that looks like a blue lake. They call this mysterious spot Umma. The Apollo 15 mission first spotted it, and the Apollo 17 mission later took clearer pictures of it. This spot, shaped like a bluish letter D, is one of the weirdest things on the moon. The color comes from special rocks rich in titanium called basalts. These rocks cover Ina's floor and make it look blue. There are also bluish areas near the edges of the mounds inside Orna. Ina was unique and probably has a long history. It might have had volcanic activity, with mounds that are about 3.5 billion years old. Our moon also has its own face, just like those on Mars. There's an area near the moon's south pole that looks like a face, but it's just a bunch of craters and shadows that happen to make an image resembling a face when seen from far away. These craters have been there for billions of years and cover about 16% of the moon's surface. Some of these craters might even have water and ice inside of them. You might be wondering why there are so many faces in our solar system. That's because our brains are wired to recognize faces even when there aren't any. It's a phenomenon called Pareidolia. Our brains try to make sense of shapes. So when we see something that looks a bit like a human, our brain turns it into one because it's familiar. Like when you see a shadow figure on a chair with clothes, or even on Mercury. Some people see shapes that look like Mickey Mouse. It's not extraterrestrial life. It's our brains playing tricks on us. This planet shouldn't exist, but it does. A newly discovered planet rotates around a star that's much smaller and dimmer than our Sun. The planet, however, is enormous. Such a tiny star couldn't have created it. So, it's like finding an ostrich egg in a chicken coop. A team at Penn State built a special tool called the Habitable Zone Planet Finder. It's an instrument that's supposed to find planets around dim, cool stars. It looks at the light from these stars, which is mostly in the near-infrared, beyond what our eyes can see. This gadget can spot changes in a star's speed caused by a planet. If a star's movement slightly changes, that means there must be a gravitational pull nearby. Years ago, this technique helped find the first known exoplanet around a star like our Sun. Today, we've improved this method to make more precise measurements. Our main goal is to find Earth-like planets that are rocky and located in habitable zones. The Doppler technique isn't that great at finding Earth-like worlds yet, but it works well for cool, dim stars. That's how we discovered the impossible. LHS 3154b. Planets usually form in disks made of gas and dust in space. These particles come together and stick to each other, creating a flat, rotating disk. Over time, these tiny bits combine to form a solid core. This is the starting point for a planet. Once the core is there, it attracts more dust and even gas. This process is called core accretion. Stars are a huge help in that process. Usually, big stars have more gravity, so they can gather more stuff to form planets. But the star we discovered recently isn't very big. It's 9 times smaller than our Sun. A star this small shouldn't have had a big enough disk to make such a heavy planet. To do that, its disk should have been at least 10 times bigger, but this heavy planet, LHS 3154 big, exists. This mysterious planet is 13 times heavier than our Earth. It's similar in size to Neptune. It's about 50 light-years away from us in the Hercules constellation. The planet is also super close to its star, completing 1 year in almost 4 days. This discovery is making scientists rethink their ideas about how planets and stars come into existence. There are new theories coming around. For example, a theory called gravitational instability says that instead of the pieces coming together bit by bit, the material in the disk collapses all at once, directly creating a planet. But even with this theory, it's hard to explain how such a heavy planet could form without a really massive disk. It'll take us some time to figure out the truth. This isn't the first planet that makes us doubt our theories. Recently, scientists found another planet called Halley. This planet is orbiting a star called Bacchus, and just like the previous one, it shouldn't really exist. It's way too close to a star. Stars change a lot during their lives. Normally, when a star becomes big and prepares to leave this world, it's called the red giant stage. A star like that tends to destroy or push away any nearby planets. Halley rotates around a red giant, and it should have been swallowed or destroyed by the expanding star a long time ago, but it's still hanging there, even though Bacchus has already started burning helium and shrunk to a smaller size than expected. Halley isn't bothered in the slightest. Scientists call Halley the Forbidden Planet. This discovery challenges what we thought about how planets survive near aging stars. It raises two theories. One suggests that Bacchus was once two stars, a white dwarf and a red giant. Halley orbited them both, and they merged before the red giant fully expanded. This allowed Halley to survive. The second theory says that Halley formed from the debris created when the two stars merged. In this scenario, Halley would be a very young planet orbiting an elderly star. Astronomers plan to continue studying Halley and look for more planets like that. Another oddball is called LTT 9779b. This one scares us because it's too shiny. The planet reflects 80% of the light from its star. Regular mirrors reflect from 85 to almost 100% of light, which means that this mysterious planet should look like a rough mirror with aluminum or silver-like reflections. This is another Neptune-sized planet. It's located 268 light-years from us and was discovered by NASA's TESS spacecraft. It completes a full rotation around its star in just 19 hours. It's so close to its star that it's scorching hot, reaching temperatures over 3,600 degrees Fahrenheit. Normally, planets this close lose their atmosphere and turn into bare rocks, but this one breaks the rules again. We know the secret of its survival: its shiny metallic clouds which are made of glass and titanium salts. These clouds rain titanium onto its hot surface. They also reflect a lot of the light, preventing the planet from getting too hot and losing its atmosphere. This planet's size also surprised scientists. It's way bigger than Earth. Other planets this close to their stars are either much bigger gas giants or small rocky planets. This planet is a smaller gas giant, and scientists didn't expect it to exist so close to its star. This is the shiniest planet ever found, even shinier than Venus. Despite its cool appearance, it's probably not a friendly place for life because of its extreme temperatures and strange metallic rain. Our final rule breaker is a planet called WASP 107b. Scientists discovered it using the James Webb Space Telescope. It's located around 208 light-years from us in the Virgo constellation. It's also fast and completes an orbit around its star in just 6 days. This is a super Neptune exoplanet. It's similar to Jupiter in some ways, including the same size and scorching hot temperatures. But the main difference is that it's much lighter, weaker, and less dense. This is the least dense planet we've discovered so far. After researching some more, we also found that it has a tail. The helium on the planet extends beyond the transit egress. The planet is slowly losing its atmosphere due to extreme ultraviolet radiation from the star. This creates a comet-like tail, so it looks like a fluffy comet. But that was just the beginning. The planet's low density, or fluffiness, allowed astronomers to study its atmosphere in detail. They found some surprising things like water vapor and clouds made of fine silicate particles, which are like really fine-grained sand. The planet's host star doesn't emit a lot of high-energy light, but since WASP-107b is so loose, the light can penetrate deep into its atmosphere. This creates sulfur dioxide, that smell you get when you light a match. In other words, it's a fluffy planet that rains sand and smells like matches. The researchers think the sand clouds in the atmosphere form in a similar way to clouds on Earth. These sand droplets condense, fall, turn into silicate vapor in hot layers within the planet, and then rise again to form clouds once more. Once again, this planet couldn't have formed in its current spot. Astronomers say that it likely moved closer to its star from a birth orbit, because it was attracted by some heavier neighbor. It also follows a retrograde orbit, meaning it orbits in the opposite direction to its star's rotation. All these discoveries are changing how we understand planets and their atmospheres, giving us new insights into the mysteries of our own solar system. These incredible planets that shouldn't exist, and these bizarre moons and structures are just the beginning of our journey. There is a whole universe of wonders out there waiting to be discovered, and as we continue to explore, we will continue to be humbled by the sheer immensity and strangeness of the cosmos. The universe is teeming with peculiar planets, and one of the most perplexing types is the so-called cotton candy planet. This scientific term refers to exoplanets with incredibly low density, making them feel light and fluffy despite their massive size. One such world is WASP-193b, a planet so light it could be mistaken for a cosmic puffball. Located approximately 1,200 light-years from Earth, this world is about 50% more massive than Jupiter, yet its density is similar to that of cotton candy. It's a true oddity, and trying to stand on its surface would be impossible. These low-density planets are a puzzle for scientists, who believe they get puffed up by the intense heat from their parent stars, causing their hydrogen and helium-rich atmospheres to expand dramatically. However, planets so close to their star typically lose their atmosphere over time, making the survival of WASP-193b a mystery. This fluffy world challenges our understanding of planetary formation and evolution. WASP-193b isn't alone in its low-density strangeness. The Kepler 51 star system, located 2,400 light-years away, hosts a family of 3 puffball planets. These worlds are enormous in size, but have the same density as cotton candy. Just like WASP-193b, scientists believe these planets are large hydrogen and helium gas balloons with a generous layer of methane haze, and they might even be in the process of shrinking as they lose their atmospheric mass over time. These discoveries are forcing astronomers to rethink how we classify and understand planets beyond our solar system. Moving from fluffy to fiery, some planets exist in a constant state of scorching heat. One of the hottest planets ever discovered is Mascara 5b, an ultra-hot Jupiter, with a dayside temperature of 4,892 degrees Fahrenheit. To put that into perspective, this temperature surpasses the melting point of most metals, and is comparable to the exhaust of a rocket engine. The night side is only slightly cooler, at 4,172 degrees Fahrenheit, making it the second hottest night side ever recorded. Life as we know it is impossible on such a world. Another fiery world is WASP-76b, a sizzling hot Jupiter-like planet where it literally rains iron. The day side of this planet reaches a temperature of 4,300 degrees Fahrenheit, vaporizing iron, which is then blown to the cooler night side where it condenses and falls as liquid iron rain. These discoveries highlight the incredible diversity and extremes of planetary environments in the universe. Some planets are peculiar, not for their size or temperature, but for their composition and appearance. For instance, the planet 55 Cancrezu was once thought to be a diamond world. Early studies suggested that the planet, a super-Earth, was so rich in carbon and subjected to such high pressures and temperatures that its interior was packed with diamonds. While more recent research has challenged the diamond planet theory, it remains a total gem for astronomers, offering a glimpse into a world with a very different chemical makeup from Earth. Another strange world is GJ 1214 b, located 40 light-years away. This planet, about 3 times the diameter of Earth, is practically drowning in water. The intense temperatures and pressures on GJ 1214 b are believed to create exotic forms of water, such as hot ice and superfluid water, materials that defy our normal understanding of physics. Beyond the bizarre exoplanets, our own solar system holds some fascinating mysteries. For example, have you ever wondered why all planets are perfectly round? The answer lies in gravity, which pulls all the material inward toward a central point. Since gravity acts equally in all directions, it forces a planet to settle into a spherical shape. This state of balance is called hydrostatic equilibrium. However, a planet's rotation can cause it to bulge at the equator, a phenomenon called oblateness. We see this clearly with Jupiter and Saturn, which spin so fast they are noticeably squashed at the poles and fat around the middle. This playful and distinct shape is a testament to the powerful combination of gravity and rotation. What if planets weren't round at all? A cube-shaped or triangular planet would have its mass spread out in a completely different way, with gravity being strongest at the center of each face. Walking on the edges would feel like climbing a steep mountain. Water would pool at the center of each face, leaving the edges barren and dry. The atmosphere would also gather at the center of each face, becoming thin and dangerous along the edges. While it's fun to imagine, our Earth loves its spherical shape, and that's a good thing for us. It's our brain that often plays tricks on us, a phenomenon known as pareidolia, causing us to see faces and familiar shapes in random patterns, such as the supposed face on Mars or the image of Mickey Mouse on Mercury. These are not signs of alien life, but rather a reflection of how our minds are wired to find patterns and recognize faces in the world around us. Our minds are wired to find patterns, making us see faces in the dust and shadows of distant worlds. But beyond these illusions, there are planets that exist in a state of genuine strangeness, defying all the rules we thought we knew. Imagine a world with no star to call its own, a cosmic wanderer drifting alone in the darkness of space. This is a rogue planet. Scientists have actually detected these celestial loners, and they believe there may be countless of them floating through our galaxy. Some are small, rocky worlds like Earth, but many are colossal gas giants, much larger than Jupiter, with their own systems of moons. One of the most famous rogue planets is known by the complicated name of CFBDSIR 2149-0403. It's about 80 light-years away and is estimated to be 6 times the mass of Jupiter. These planets aren't completely cold either. They can generate heat and even light from their own internal processes, which means they could potentially be habitable. Life on such a planet would be a lonely existence, with no warm sun to bask in and no neighboring worlds to see. To survive, we would have to get creative, harnessing the planet's internal heat through geothermal energy to power our homes and cities. These settlements would likely be built underground, closer to the heat source. For light, we could engineer bioluminescent organisms to illuminate our living spaces, creating subterranean worlds aglow with neon mushrooms and plants. As for food, without a star, we would rely on the same geothermal vents and chemical reactions to sustain ourselves. The biggest challenge would be the lack of a stable atmosphere, which could be incredibly thin or non-existent. We would have to create our own breathable air and build advanced biospheres to grow food and generate oxygen. The most exciting possibility is the existence of underground oceans, which scientists speculate could exist on some of these planets. These oceans could provide a source of water and other resources, and they might even be home to bizarre creatures that have adapted to life in the dark. Living on a rogue planet would be full of challenges, but it could also be an incredible adventure. Our journey to other worlds might not require us to adapt to them, but to adapt ourselves. While natural evolution is a long process, genetic modifications could one day allow us to survive and thrive on other planets. Scientists could alter our genes to make us more resistant to the extreme temperatures and radiation found in space. They could also tackle the effects of low gravity on our muscles and bones, making us stronger and more resilient. However, the technology for safe and precise genetic modifications is still in its early stages, so it might take as long for us to develop it as it would for our bodies to naturally evolve. Nevertheless, there are some planets where we might not need to change much at all. One such planet is Gliese 667 cc, which we can call Gary for short. Gary gets about 90% of the light that Earth does, but in the form of infrared light. This makes the world a bit darker than Earth, but not necessarily colder. It is also estimated to have a stronger gravitational pull, which would require us to develop stronger muscles and bones over generations. We still know too little about these exoplanets to move there anytime soon, so for now we will focus on the planets in our own solar system. We can eliminate the two ice giants, Neptune and Uranus, as well as the two gas giants, Saturn and Jupiter, from our list of potential homes. Terraforming them is simply not a possibility. However, we have 4 other very cool candidates: Venus, Mars, Jupiter's moon Callisto, and Saturn's moon Titan. Some of Jupiter's moons are packed with water, but only Callisto is far enough away from Jupiter's dangerous radiation belts. On Earth, we get about 0.24 rems of radiation per year. Callisto only gets about 0.01 rems per day, which humans can totally handle. However, Callisto is an icy wonderland, so we would need to pack our best protective clothing and high-tech heating systems. Titan, Saturn's largest moon, is like a treasure chest of resources waiting to be unlocked. Its atmosphere is a nitrogen party, just like early Earth's, and it has vast reserves of hydrocarbons. We could potentially transform Titan into a modern Earth-like atmosphere by using giant space mirrors to heat the surface and release water vapor. This would create an oxygenated atmosphere. Titan also hangs out within Saturn's magnetosphere, which shields it from harmful solar winds. However, Titan's gravity is only about 1/7 that of Earth, which could lead to muscle and bone deterioration over time. To counteract this, our bodies would need to develop stronger muscles and denser bones. This is why we might need to hit the gym more often than we do here on Earth. Now, when it comes to being the hottest planet, Mercury may be the Sun's next-door neighbor, but Venus takes the crown. The average temperature there is a scorching 870 degrees Fahrenheit. It's like trying to survive in a pot of boiling water. The surface is covered in thick clouds of sulfuric acid that would dissolve any human who tried to visit. No amount of evolution or genetic modification could turn us into superhumans who could handle Venus's extreme conditions. On the other hand, Mars is a much more promising candidate. A bigger Mars would have a stronger magnetic field and gravity, which would lead to a richer and denser atmosphere, possibly even with oxygen. A denser atmosphere could also distribute heat across the planet, making it much warmer, and a stronger gravitational pull could stabilize liquid water on its surface. However, a new Mars would also have a volcanic personality, with more frequent and crazy volcanic eruptions. While it would be exciting to witness such eruptions on another planet, it would also be incredibly dangerous. Speaking of crazy, have you ever wondered if Earth itself is an intelligent entity, not a creature, but a complex system that can take care of itself? This idea suggests that the collective activity of life, from microbes to plants to animals, can change a planet and give it a life of its own. It's like the planet has a green mind. Researchers believe we should measure a planet's intelligence by its ability to keep itself going forever. Just as humans need to work together to survive, a planet's collective intelligence is measured by the capacity of all the life on it to work together toward this same goal. The metaphor of Earth as a living planet makes sense when you consider how forests can share nutrients through their secret underground networks of fungi, helping all the trees stay healthy. We are currently in a stage called the immature technosphere, where our technology doesn't always do good for our planet. The goal is to move to a mature technosphere, where technology will benefit the entire planet, using sustainable forms of energy like solar power. This concept of planetary intelligence is a sign of a mature planet, and it is something we should strive for. It's hard to imagine planets could become sentient, like the world of Pandora from Avatar. Planets form from the gathering of materials like rocks, gases, and liquids, not from chemical reactions that lead to self-replicating molecules. Furthermore, having a big brain is expensive for any organism, and animals only become as smart as they need to be to survive. It's also difficult to imagine all living beings and plants on a planet reaching the same level of intelligence needed for global cooperation. The rule of the animal kingdom is all about survival of the fittest, with creatures constantly competing for resources. While some species like ants work together in a hive mind, this kind of competition is not a good base for global cooperation. So while the dream of a conscious planet like Pandora is a nice thought, it is highly unlikely to be a reality. The incredible discoveries we've made in the last few years are changing how we understand planets and their atmospheres, giving us new insights into the mysteries of our own solar system. From planets that shouldn't exist to worlds with exotic forms of water and metallic clouds, the cosmos is full of wonders that challenge our imagination and expand our knowledge. The journey of exploration is just beginning, and we can only imagine what other secrets the stars hold for us. Our understanding of the cosmos is a tapestry woven from observations, and every new thread of discovery challenges our previous assumptions. The more we look out into the deep black, the more we find worlds that shouldn't exist, and yet they do. We've encountered a planet so strange that it's been dubbed the Forbidden Planet. This world, named Halley, orbits a star called Baikal, a red giant that should have swallowed it long ago. Stars like our Sun, when they reach the end of their life cycle, expand into red giants, a stage that typically engulfs or pushes away any planets in their path. But Halley, orbiting its aging star, remains in place. This discovery has forced scientists to develop new theories about how planets survive the death throes of their parent stars. One theory suggests that Baikal was once a binary system of two stars that merged, a white dwarf and a red giant. The helium from the white dwarf may have prevented the red giant from expanding far enough to destroy its planet. Another theory proposes that Halley is a very young planet that formed from the debris of the merging stars. Whatever the reason, Halley is a testament to the unpredictable nature of the universe. Another world that defies the laws of planetary formation is LHS 3154b. This massive planet orbits a star that is 9 times smaller and dimmer than our Sun. According to current models, a star so small shouldn't have been able to gather enough material to form such a large planet. The process of planet formation, known as core accretion, requires a vast disk of dust and gas. A small star would have a small disk, and a small disk would not have enough material to form a planet 13 times heavier than Earth. This discovery has led astronomers to consider alternative theories, such as gravitational instability, which suggests that planets can form from a rapid, all-at-once collapse of material in a stellar disk. But even this theory struggles to explain how a star as small as LHS 3154's could produce a planet so large. This cosmic mystery reminds us that the universe is far more complex than we can imagine. From the impossible to the bizarre, we now turn our attention to the shiniest planet ever found, LTT 9779b. This world reflects an astonishing 80% of the light from its star, giving it the appearance of a rough silver mirror. The planet is a hot, Neptune-sized gas giant that orbits its star in just 19 hours, reaching temperatures over 3,600 degrees Fahrenheit. Planets this close to their stars are usually stripped of their atmospheres by the intense heat and radiation, but LTT 9779b has survived. Scientists believe its secret is a reflective shield of clouds made of glass and titanium salts. These metallic clouds not only reflect light, but also rain titanium onto the planet's surface, preventing it from losing its atmosphere. The existence of such a planet forces us to reconsider what is possible in the universe. Some planets are strange not because of what they are, but because of what they aren't. They are the cotton candy planets, worlds with massive size but incredibly low density. Take WASP 193b, for example. This planet is 50% more massive than Jupiter, but its density is so low it's comparable to cotton candy. Its atmosphere is puffed up by the heat of its star, but it has somehow retained its fluffy state. The Kepler 51 system is another example, hosting 3 planets with the density of cotton candy. These worlds are believed to be large gas balloons with a generous layer of methane haze, and they may be in a cosmic process of shrinking as they lose their atmospheric mass over time. These discoveries challenge our models of planetary formation and evolution, suggesting that there are still many secrets hidden in the stellar nurseries of our galaxy. Then there are the planets of pure, unadulterated fire. Mascara 5b is an ultra-hot Jupiter, a planet almost twice the size of our own Jupiter, with a dayside temperature of 4,892 degrees Fahrenheit. This temperature is hot enough to melt most metals, and is hotter than molten lava. The night side is not much cooler, making it the second hottest night side ever recorded. Life as we know it is impossible on such a world. Even more extreme is WASP 76b, a planet where it literally rains iron. The scorching day side of this planet, which reaches 4,300 degrees Fahrenheit, vaporizes iron and other metals. These vapors are then blown to the planet's cooler night side, where they condense into liquid and fall as a terrifying metallic rain. These planets are a vivid reminder of the extreme conditions that can exist on worlds beyond our solar system. Not all strange planets are so violent. Some are fascinating for their unique composition. The planet 55 Cancri E, Super Earth, was once believed to be a diamond world. Early scientific speculation suggested that the planet's interior, due to its high carbon content and immense pressure, was a solid mass of diamonds, while later research has cast doubt on this theory. it remains a captivating idea, a world of pure sparkle. Another example is GJ 1214b, a water world located 40 light-years away. This planet, 3 times the diameter of Earth, is believed to be almost entirely covered in water. The intense heat and pressure on the planet create exotic forms of water that do not exist on Earth, such as hot ice and superfluid water. These worlds are a reminder that the universe can produce materials and forms of matter that are alien to our experience. The biggest challenge in exploring these worlds is our own fragile biology. Our bodies are not built for the unforgiving conditions of space, and long-term exposure to low gravity and cosmic radiation can have devastating effects on our muscles, bones, and organs. For us to become a truly multi-planetary species, we may need to adapt ourselves. One solution is through genetic modification. Scientists could potentially alter our genes to make us more resistant to radiation or to grow stronger bones and muscles that can withstand the effects of low gravity. But this is a futuristic solution, and for now we must rely on technology to protect us. The search for habitable planets is an ongoing quest, and it begins with finding a world where we might not have to change so much at all. This brings us to a thought experiment. What if every planet in our solar system was the size of Earth? This mind-bending scenario would drastically change the conditions on each world. Mercury, the smallest planet, would become a volcanic inferno, similar to Venus, as its increased mass and gravity would lead to a thicker atmosphere and more intense internal heating. Venus, already our twin, would remain largely the same, a hostile world with a poisonous atmosphere and scorching temperatures. But Mars, the red planet, would become a lush green oasis. A larger Mars would have stronger gravity and a more stable magnetic field, which could lead to a thicker atmosphere with liquid water on its surface. It would still be a geologically active world with frequent volcanic eruptions, but it would be a much more viable home for humanity. On the other hand, a smaller Jupiter and Saturn would be a disaster for us. Jupiter's gravity acts as a cosmic shield, deflecting thousands of asteroids and comets away from the inner solar system. A smaller Jupiter would no longer provide this protection, leaving Earth vulnerable to more impacts. Saturn's famous rings would also disappear, as the planet's weaker gravity would cause the chunks of ice and rock to either fall onto the planet or scatter into space. Uranus and Neptune, the ice giants, would also be transformed. A smaller Uranus would be warmer, while a smaller Neptune could become a rocky planet with a thinner, less dense atmosphere. This thought experiment shows us just how unique and special our own solar system is. As we continue to explore, we are beginning to understand our own planet in a new light. The idea of Earth as a living entity, an intelligent planet, is gaining traction. It's not about a conscious planet with a brain, but about the collective intelligence of all life on Earth, from microbes to animals, working together to maintain a stable, life-sustaining system. This concept is known as the biosphere. We are currently in a stage called the immature technosphere, where our technology often harms the planet rather than helps it. The goal is to reach a mature technosphere, a stage where our technology works in harmony with the biosphere. We can learn a lot from this idea, and it reminds us that our own actions matter in the grand scheme of things. To truly appreciate the conditions on other worlds, imagine trying to run on them, on Mercury, where gravity is only 38% of Earth's. You would feel incredibly light. Despite the bulky spacesuit, you could achieve a speed of 13 miles per hour, faster than the average person on Earth. On Mars, with similar gravity, you could reach a speed of 12 miles per hour, but you would have to contend with a ground covered in fine, rusty dust. On Venus, where gravity is almost the same as Earth's, you would be able to run a bit faster at 8.5 miles per hour, but a run on Jupiter or Saturn would be impossible. Jupiter's gravity is over twice that of Earth's, making it difficult to even walk. You would also have to deal with winds that can reach speeds of 200 to 400 miles per hour. This thought experiment shows us that even the simplest of human activities, like running, would be a monumental challenge on other planets. These incredible discoveries and thought experiments are not just about finding new worlds, but about understanding our place in the universe and the uniqueness of our own home. The incredible discoveries we've made in our galaxy are not just about finding the bizarre, but also about finding the exceptional. Scientists have compiled a new list of planets that are not just Earth-like, but are considered superhabitable, with conditions even better suited for life than our own. One such candidate is a planet orbiting a star known as KOI 5715.01, an orange dwarf that is slightly smaller and dimmer than our Sun, but will live for billions of years longer. This longevity is a huge advantage, as it gives life on its planets more time to form and evolve. The planet itself, about 5.5 billion years old, is nearly twice the size of Earth. Its larger radius means more space and a stronger gravitational pull that can hold onto a thicker atmosphere, offering better protection from space. The average temperature is a cool 52 degrees Fahrenheit, but the strong gravity helps the planet retain heat, making it feel warmer. While it's located some 3,000 light-years away, this world is a prime example of a place that could be a superior home to our own. Another fascinating world on this list is KOI 3101. This planet orbits an orange dwarf and is a very pleasant world indeed. With an average temperature of 67 degrees Fahrenheit, it's slightly warmer than Earth, which scientists believe is a perfect temperature for the development of life. Its radius is nearly 1.5 times larger than Earth's, and it likely has a rich atmosphere and a vast ocean covering up to 60% of its surface. The resemblance to Earth is so striking that scientists estimate there is an 84% chance of finding life there. If there were creatures on such a world, they would likely be big but have a low height and strong, sturdy legs to handle the stronger gravity. Unfortunately, for now, these planets are just tiny dots in space, and we only have dry, data-driven assumptions about them. We can't talk about superhabitable worlds without mentioning Kepler 186f, nicknamed Earth's cousin. It's located near a red dwarf, a star even smaller and dimmer than an orange dwarf. Kepler 186f is located closer to its star than we are to our Sun, but because its star is so dim, it wouldn't be too dark there. The sky on this planet would be an unusual shade of red, a world with an eternal sunset. The planet's size and tilt are similar to Earth's, which means it would have stable seasons and a normal day-night cycle, crucial factors for life to flourish. Another important detail is that there is likely an ocean on Kepler 186. Oceans act as a thermal regulator, absorbing heat and distributing it evenly across the planet, which would help stabilize temperatures. This is a very promising world, but at 490 light-years away, interstellar travel is a long way off. The Kepler-62 system offers two more superhabitable candidates, Kepler-62e and Kepler-62f. These planets are located 1,200 light-years away and both orbit a red dwarf. Kepler-62e is about 1.5 times larger than Earth, while Kepler-62f is just slightly smaller. Scientists believe they are both water worlds, warm places mostly, or even completely covered with water. If there is any land, it would likely be small islands. The idea of a world consisting entirely of islands is a dream for some, but perhaps a nightmare for others. The existence of these planets confirms that the universe is not just filled with strange and extreme worlds, but also with familiar and potentially nurturing ones. To truly understand the strange conditions on these worlds, we can take a little thought experiment right here in our own solar system. Imagine if you could run on each of the planets. On Earth, the average person runs at 6 to 8 miles per hour. On Mercury, with its gravity being only 38% of ours, you would weigh a mere 58 pounds. Despite the bulky spacesuit, you could achieve a speed of 13 miles per hour, almost twice your normal speed. The surface of Mercury, however, is covered in craters, making your run a hazardous one. A run on Venus would be different. Its gravity is almost the same as Earth's, so you would run at a speed of about 8.5 miles per hour. The main challenge would be the super dense atmosphere and the clouds of sulfuric acid. Your first step on Mars would feel strangely light, as your weight would be only 58 pounds. This would help you achieve an impressive speed of 12 miles per hour. However, the ground is covered in rusty dust, which can get into everything. Dust storms can also cover the entire planet, forcing you to find shelter quickly. A run on Jupiter or Saturn is an entirely different matter. As gas giants, they have no solid surface. If you tried to step on them, you would simply fall into the planet. But if you could run on Jupiter, its gravity, which is over twice that of Earth's, would make it nearly impossible to even walk. You would also have to contend with wind speeds of 200 to 400 miles per hour. On Saturn, the gravity is similar to Earth's, but the wind speeds are even higher. Your running adventure would have to take place entirely in your imagination, as these gas giants are far from solid ground. The running tour of our solar system continues, moving beyond the rocky inner worlds and into the realm of giants. If you could step onto Jupiter, you would immediately feel its immense gravitational pull, which is more than twice that of Earth. Simply standing would be an exhausting effort, and running would be nearly impossible. Its atmosphere is a chaotic sea of hydrogen and helium, swirling with winds that can reach speeds of 200 to 400 miles per hour. As a gas giant, it has no solid surface to speak of, so you would be perpetually falling through layers of storms and clouds. The same is true for Saturn, which also lacks a firm surface. While its gravity is surprisingly similar to Earth's, you would still be lost in an endless descent through its cold, dense atmosphere. Your running journey would have to remain entirely in your imagination on these magnificent but inhospitable worlds. Continuing our journey outward, we arrive at the ice giants, Uranus and Neptune. Uranus, with its beautiful blue-green color, is a world of swirling ice and gas. Like its larger cousins, it has no solid surface. You would simply plummet through its atmosphere of hydrogen, helium, and methane. Its gravity is slightly less than Earth's, but the extreme cold and violent hurricanes, which can span over 600,000 miles, would make any attempt at movement futile. Neptune, the farthest planet from the Sun, is a cold, dark world with a gravity slightly stronger than Earth's. Its surface is a permanent layer of swirling gas and clouds, and its mantle is made of water, ammonia, and methane ices. Like the other giants, it offers no solid ground for you to land on. This thought experiment shows us how unique and precious our own planet's solid ground truly is. As scientists continue to explore the vast expanse of the universe, they've made incredible discoveries that have changed our perspective. The year 2022 was a landmark year for exoplanet discoveries, revealing worlds stranger than we could have ever imagined. One of the most groundbreaking finds was a new type of exoplanet orbiting red dwarf stars. These worlds, found to be half rock and half water, likely formed in the icy regions far from their stars and then migrated inward. This discovery has huge implications for the search for life, as these water-rich worlds could be prime candidates for hosting some form of life. Another perplexing discovery was a Jupiter-sized world, 2I-280b, orbiting a star 379 light-years away. This planet's year lasts a whopping 261 days, much longer than most distant gas giants we've found so far. Its temperature is also surprisingly mild at about 170 degrees Fahrenheit. This planet acts as a bridge between the giant exoplanets we've found and our own Jupiter, and scientists are still trying to figure out how it came to be so different. Then there's the Hulk planet, 2I-1075b, a massive super-Earth located 200 light-years away. Its surface is covered in molten magma, and it reaches scorching temperatures of 1922 degrees Fahrenheit. It's one of the most massive super-Earths ever discovered, and its orbit is so short that its year lasts only 14.5 hours. Among the more ominous discoveries of 2022 were 3 doomed planets circling slowly fading stars. Just a decade ago, scientists never imagined such planets could exist. These gas giants, similar in size to Jupiter, orbit so close to their aging stars that they are walking on a cosmic tightrope. One of them, OI-2337b, will likely be swallowed by its star in less than 1 million years. As these planets get closer to their stars, their atmospheres heat up and swell, creating mind-boggling differences in density. Studying these doomed worlds could give us valuable insights into the evolution of our own solar system and what might happen to Earth in the distant future. The strangeness of these planets extends to their very atmospheres. Scientists discovered 2 super Jupiters, WASP-76 and WASP-121b, with atmospheres made of the heavy element barium. These planets are so hot that they vaporize iron on their day sides, which then falls as rain on the cooler night sides. The presence of a heavy metal like barium high in their atmospheres is a complete mystery, challenging our understanding of planetary physics. Another bizarre world is the football planet, WASP-103b, an ultra-hot exoplanet that is so close to its star that its intense gravitational forces are stretching it into an oblong, football-like shape. This discovery was the first time we were able to measure a planet's deformation from a distance, offering new insights into the extreme conditions these worlds can endure. Beyond planets, astronomers have also found a spooky phenomenon called zodiacal light on 3 distant super-Earths. This glow, similar to the one seen on Earth during sunset, is caused by sunlight reflecting off dust particles left behind by asteroids and comets. This discovery is more than just a light show. It could reveal the presence of asteroids and comets in these exoplanet systems, which are otherwise difficult to detect. Finally, scientists discovered the brown dwarf VHS 1256b, a strange and exotic world shrouded in mystery. This object, which blurs the line between planet and star, is cloaked in thick clouds of fine silicate grains, essentially sand. It's the first time this type of cloud has ever been detected on such a celestial body, and it's a discovery that's sure to change the way we think about the possibilities of life beyond our world. As we look at these incredible discoveries, it becomes clear that our universe is far more diverse and strange than we ever imagined. Each new planet and celestial body we find is a clue, a piece of the cosmic puzzle that helps us understand our place in the vastness of space. The journey of discovery is just beginning, and we can only wonder what other marvels await us as we continue to look to the stars. Our journey through the cosmos now takes us to a world that is not a chaotic maelstrom of gas or a scorched desert of rock, but an endless ocean. Imagine yourself in the middle of a vast, foggy sea with no land in sight. Thick clouds hide the sun, making it impossible to tell if it's day or night. As you dive below the surface, the depth is staggering, and the pressure becomes immense. This is a typical water world, a planet that consists mostly of water and ice. On Earth, our oceans make up less than 0.1% of the planet's mass. On a true ocean planet, water can make up 40% to 60% of the total mass, with depths that can exceed 60 miles. The pressure at these depths would be crushing, reaching up to 20,000 times the atmospheric pressure of Earth. Yet, according to scientific calculations, these planets may be quite common in our galaxy. The first ocean planet we discovered was Gliese, 1214b. Initially, it appeared as a small dim dot orbiting a red dwarf star that is 5 times smaller and 300 times dimmer than our Sun. But scientists soon realized this world was unique. This super-Earth is 2.5 times larger than our planet, but has a very low density, suggesting it is composed primarily of water and ice, not rock or metal. Gliese, 1214b orbits incredibly close to its star, with a year lasting only 36 hours. The temperatures there are scorching, with an average of 250 to 535 degrees Fahrenheit. The ocean would be constantly in a state of near boiling, with a blurred boundary between the water and the steam in the atmosphere. The bottom of this immense ocean is believed to be covered in a thick layer of hot ice, a substance that remains solid despite the gigantic temperatures due to the crushing pressure. Another fascinating candidate for a water world is 2I-452b, a planet located nearly 100 light-years away in the Dragon constellation. Discovered by the TESS telescope, this planet is 7 times larger than Earth, but a surprising 48 times heavier. Its very low density suggests that it too is a giant ocean world. Unlike Gliese 1214b, however, this planet likely has a rocky surface deep beneath the water, similar to our own oceans. 2I-452b orbits, not one but 2 red dwarfs, and it is located far away from its stars, at a distance 2.5 times greater than Pluto is from our Sun. A year on this planet lasts only 11 days, and we are eagerly awaiting more data from the James Webb Space Telescope to unravel its mysteries. While we can't confirm the presence of life, these water worlds give us hope that there are places in the universe where the fundamental building block of life is abundant. The hunt for life in the cosmos is tireless, and it has led us to a new list of planets that are not just Earth-like, but are considered superhabitable worlds. One such world is KOI 5715.01, a planet orbiting a long-lived orange dwarf star. Our Sun has a lifespan of about 10 billion years, while orange dwarfs can live for up to 70 billion years, giving their planets a much longer window for life to evolve. This planet, already 5.5 billion years old, is nearly twice the size of Earth. Its larger radius means more space and a stronger gravitational pull that can hold onto a thicker atmosphere, offering better protection from space radiation. Its average temperature is a comfortable 52 degrees Fahrenheit, but the strong gravity helps it retain heat, making it feel warmer and more hospitable. Another promising candidate is KOI 3101, a planet that scientists believe has an 84% chance of hosting life. It has an average temperature of 67 degrees Fahrenheit, which is slightly warmer than Earth and is considered ideal for fostering life. Its radius is nearly 1.5 times larger than Earth's, and it likely has an extensive ocean covering up to 60% of its surface. This world is so similar to our own that it makes us wonder if there are planets out there that are just a little bit better at being a home for life. This brings us to a planet nicknamed Earth's cousin, Kepler 186f. This world, located 490 light-years away, is similar in size to our own and orbits a red dwarf. The planet's tilt is about the same as Earth's, which means it should have stable seasons and a regular day-night cycle. The red dwarf's low luminosity gives the planet a reddish sky, a world with an eternal sunset. These planets prove that the universe is not just filled with strange and extreme worlds, but also with nurturing ones that could one day be our home. The concept of a second Earth is not just a fantasy. We have already found one of the best candidates, Kepler 22b. This is the first planet found in a habitable zone by the Kepler telescope, located 635 light-years away in the Cygnus constellation. Its host star, Kepler 22, is a yellow dwarf, almost identical to our Sun in size and age. Kepler 22b is about 2.4 times larger than Earth, giving it more space and a greater potential for water. However, its mass is unknown, and it could be up to 36 times heavier than Earth. If this were the case, the gravity would be 6 times stronger, making it incredibly difficult to move and for plants to grow. Any animals on such a planet would likely be short, massive, and extremely strong. But if the gravity is only slightly stronger than Earth's, then it would be a much more livable world. Kepler 22b is about 15% closer to its star than Earth is to the Sun. Since its star is about 20% dimmer, the temperature on the planet would likely be similar to ours. We also know that a year on Kepler 22b is 290 Earth days and has no natural satellites. The biggest mystery about Kepler 22b is whether it is a rocky planet, a gas giant, or a water world. If it is a rocky planet, the nature of its atmosphere is a crucial question. If its atmosphere is anything like Venus's, we would have to live underground to survive. But if it is a water world, the ocean would help regulate the temperature, and we could potentially build an underwater city there. The possibilities with Kepler 22b are endless, but until we can get more data, it remains one of the most intriguing mysteries in the universe. Our understanding of what makes a planet habitable is constantly evolving. But what about worlds that are not only habitable but might be superhabitable worlds, with conditions even better suited for life than our own? One such world is KOI 5715.01, a planet orbiting an orange dwarf star. Our Sun has a lifespan of about 10 billion years, while orange dwarfs can live for up to 70 billion years. This incredible longevity gives life on their planets a much longer window to form and evolve. This planet, already 5.5 billion years old, is nearly twice the size of Earth. Its larger radius means more space and a stronger gravitational pull that can hold onto a thicker atmosphere, offering better protection from cosmic radiation. The average temperature is a cool 52 degrees Fahrenheit, but the strong gravity helps the planet retain heat, making it feel warmer and more hospitable. While it's located some 3,000 light-years away, this world is a prime example of a place that could be a superior home to our own. Another promising world is KOI 3101, a planet that scientists believe has an 84% chance of hosting life. It has an average temperature of 67 degrees Fahrenheit, which is slightly warmer than Earth and is considered ideal for fostering life. Its radius is nearly 1.5 times larger than Earth's, and it likely has an extensive ocean covering up to 60% of its surface. This world is so similar to our own that it makes us wonder if there are planets out there that are just a little bit better at being a home for life. This brings us to a planet nicknamed Earth's cousin, Kepler 186f. This world, located 490 light-years away, is similar in size to our own and orbits a red dwarf. The planet's tilt is about the same as Earth's, which means it should have stable seasons and a regular day-night cycle, which are crucial factors for life to flourish. The red dwarf's low luminosity gives the planet a reddish sky, a world with an eternal sunset. These planets prove that the universe is not just filled with strange and extreme worlds, but also with nurturing ones that could one day be our home. The concept of a second Earth is not just a fantasy. We have already found one of the best candidates, Kepler 22. This is the first planet found in a habitable zone by the Kepler telescope, located 635 light-years away in the Cygnus constellation. Its host star, Kepler 22, is a yellow dwarf, almost identical to our Sun in size and age. Kepler 22b is about 2.4 times larger than Earth, giving it more space and a greater potential for water. However, its mass is unknown, and it could be up to 36 times heavier than Earth. If this were the case, the gravity would be 6 times stronger, making it incredibly difficult to move and for plants to grow. Any animals on such a planet would likely be short, massive, and extremely strong. But if the gravity is only slightly stronger than Earth's, then it would be a much more livable world. Kepler 22b is about 15% closer to its star than Earth is to the Sun. Since its star is about 20% dimmer, the temperature on the planet would likely be similar to ours. We also know that a year on Kepler 22b is 290 Earth days, and it has no natural satellites. The biggest mystery about Kepler 22b is whether it is a rocky planet, a gas giant, or a water world. If it is a rocky planet, the nature of its atmosphere is a crucial question. If its atmosphere is anything like Venus's, we would have to live underground to survive. But if it is a water world, the ocean would help regulate the temperature, and we could potentially build an underwater city there. The possibilities with Kepler 22b are endless, but until we can get more data, it remains one of the most intriguing mysteries in the universe. As scientists continue to explore the vast expanse of the universe, they've made incredible discoveries that have changed our perspective. The year 2022 was a landmark year for exoplanet discoveries, revealing worlds stranger than we could have ever imagined. One of the most groundbreaking finds was a new type of exoplanet orbiting red dwarf stars. These worlds, found to be half rock and half water, likely formed in the icy regions far from their stars and then migrated inward. This discovery has huge implications for the search for life, as these water-rich worlds could be prime candidates for hosting some form of life. Another perplexing discovery was a Jupiter-sized world, 2I 280b, orbiting a star 379 light-years away. This planet's year lasts a whopping 261 days, much longer than most distant gas giants we've found so far. Its temperature is also surprisingly mild at about 170 degrees Fahrenheit. This planet acts as a bridge between the giant exoplanets we've found and our own Jupiter, and scientists are still trying to figure out how it came to be so different. Then there's the Hulk planet, 2I 1075b, a massive super-Earth located 200 light-years away. Its surface is covered in molten magma, and it reaches scorching temperatures of 1922 degrees Fahrenheit. It's one of the most massive super-Earths ever discovered, and its orbit is so short that its year lasts only 14.5 hours. Among the more ominous discoveries of 2022 were 3 doomed planets circling slowly fading stars. Just a decade ago, scientists never imagined such planets could exist. These gas giants, similar in size to Jupiter, orbit so close to their aging stars that they are walking on a cosmic tightrope. One of them, 2E 2337b, will likely be swallowed by its star in less than 1 million years. As these planets get closer to their stars, their atmospheres heat up and swell, creating mind-boggling differences in density. Studying these doomed worlds could give us valuable insights into the evolution of our own solar system and what might happen to Earth in the distant future. The strangeness of these planets extends to their very atmospheres. Scientists discovered two superjupiters, WASP 76b and WASP 121b, with atmospheres made of the heavy element barium. These planets are so hot that they vaporize iron on their day sides, which then falls as rain on the cooler night sides. The presence of a heavy metal like barium high in their atmospheres is a complete mystery, challenging our understanding of planetary physics. Another bizarre world is the football planet, WASP 103b, an ultra-hot exoplanet that is so close to its star that its intense gravitational forces are stretching it into an oblong, football-like shape. This discovery was the first time we were able to measure a planet's deformation from a distance, offering new insights into the extreme conditions these worlds can endure. Beyond planets, astronomers have also found a spooky phenomenon called zodiacal light on 3 distant super-Earths. This glow, similar to the one seen on Earth during sunset, is caused by sunlight reflecting off dust particles left behind by asteroids and comets. This discovery is more than just a light show. It could reveal the presence of asteroids and comets in these exoplanet systems, which are otherwise difficult to detect. Finally, scientists discovered the brown dwarf VHS 1256b, a strange and exotic world shrouded in mystery. This object, which blurs the line between planet and star, is cloaked in thick clouds of fine silicate grains, essentially sand. It's the first time this type of cloud has ever been detected on such a celestial body, and it's a discovery that's sure to change the way we think about the possibilities of life beyond our world. The human body's limitations in space are a major obstacle to interstellar travel. The effects of microgravity on our muscles, bones, and organs are profound. Our bones lose density, our muscles atrophy, and our cardiovascular system struggles to function. To address these challenges, scientists are exploring radical solutions, including genetic modification. By altering our DNA, we could potentially make our bodies more resilient to the harsh conditions of space. We could develop genes that promote stronger bone and muscle growth in low-gravity environments, or genes that increase our resistance to the harmful effects of cosmic radiation. While this technology is still in its early stages, it offers a glimpse into a future where humans are not just space travelers, but a species truly adapted to life among the stars. The idea of making other planets habitable, a process known as terraforming, is another avenue we are exploring. In our own solar system, Mars is a prime candidate. Its thin atmosphere and lack of a strong magnetic field make it a cold, red desert, but with a stronger gravitational pull, a terraformed Mars could have a thicker atmosphere and stable liquid water on its surface. However, a larger Mars would also have a volcanic personality, with frequent and powerful eruptions. Another promising candidate is Saturn's moon, Titan. Its atmosphere is already rich in nitrogen, similar to early Earth. With giant space mirrors to heat the surface, we could create an oxygenated atmosphere and release water vapor. Titan's gravity is also 1/7 that of Earth's, which would require us to develop stronger muscles and bones over generations to adapt. But not all planets are good candidates for terraforming. Venus, for example, is a lost cause. Its average temperature of 870 degrees Fahrenheit and its atmosphere of sulfuric acid make it a fiery hellscape where no life could survive. The only beings that could theoretically survive there are tardigrades, tiny, cute critters that are incredibly tough, but even they would struggle in Venus's extreme conditions. These tiny water bears can survive boiling water, the vacuum of space, and freezing temperatures, but their recent research proves that even they won't survive on Venus. This makes our own Earth a truly unique and special place. The journey of discovery is just beginning, and we can only imagine what other marvels await us. The universe is a vast and mysterious place, filled with planets that defy our expectations and challenge our understanding. As we continue to explore, we will continue to question everything we know and be humbled by the sheer immensity and strangeness of the cosmos. Our journey into the cosmos now takes us to a place that challenges our most fundamental ideas about what a planet can be. We have found worlds that are essentially giant oceanic spheres. Imagine a planet where the only landscape is a horizon of water stretching infinitely in every direction. This is the reality of a water world. Scientists have long speculated that planets with oceans far deeper and vaster than our own could exist, and we have now found some. These worlds are defined by an ocean that can make up over 40% of their mass, creating a crushing pressure at the depths that would dwarf the Mariana Trench. One of the first confirmed ocean planets was GJ 1214b, a world discovered as a small dim dot orbiting a red dwarf star. This super-Earth is 2.5 times the size of our planet, but has a remarkably low density, leading scientists to conclude it is a water world, orbiting incredibly close to its star. Its year lasts just 36 hours. The surface of the ocean is a hot, steamy realm with temperatures soaring between 250 and 535 degrees Fahrenheit. Below the surface, the intense pressure forces water into an exotic state known as hot ice, a solid form of water that exists at extremely high temperatures. The thickness of this hot ice layer could be thousands of miles deep, separating the ocean from the planet's rocky core. Another fascinating water world is 2I 452b, a planet in the Dragon constellation that orbits not one but 2 red dwarf stars. Unlike its hot counterpart, this world is located at a great distance from its stars, 2.5 times farther than Pluto is from our Sun. Despite this distance, its year is a swift 11 days. The low density of this planet suggests it is also a water world, but with one key difference: it likely has a rocky seabed far beneath the crushing depths, a feature that could be a crucial ingredient for life to form. The question of life on these water worlds is a complex one. While the presence of water is a fundamental requirement, the absence of land and the immense pressure could prevent the formation of the complex minerals and chemical reactions necessary for life to arise. However, the possibility of life in the form of deep-sea hydrothermal vents or unique aquatic ecosystems remains an exciting prospect. The search for life is not limited to these ocean worlds. Astronomers have identified a list of superhabitable planets, worlds that possess characteristics even more conducive to life than our own. These worlds orbit stars with longer lifespans than our Sun, giving life billions of years more to evolve. They are often slightly larger than Earth, with a stronger gravitational pull that helps them maintain a thicker, more protective atmosphere. They also have a more stable axial tilt, which prevents the extreme climate changes that can threaten a planet's ability to host life. One such world, Kepler 186f, is similar in size to Earth and has a stable tilt, but its unique characteristic is that it orbits a red dwarf, giving it a perpetually reddish sky, a world of an eternal sunset. The ultimate example of a potential second Earth is Kepler 22b, a planet located in the habitable zone of a Sun-like star. This world is about 2.4 times larger than Earth, and its host star is nearly identical to our own. While its mass and composition remain a mystery, its location and size make it an ideal candidate for further study. The immense size of Kepler 22b means that its gravity could be much stronger than Earth's, which would have a profound impact on any life that exists there. Plants would have to be incredibly sturdy to rise from the ground, and animals would likely be short and powerful to handle the constant gravitational pull. The possibility of this world being a water world is also a fascinating one, as a giant ocean could regulate its temperature and create a stable, life-sustaining environment. Our understanding of planets is not just limited to those that orbit stars. We have also found worlds that wander through the galaxy alone, unbound by the gravitational pull of any sun. These rogue planets are cosmic nomads, and their existence challenges our very notions of planetary life. On such a world, there would be no day and no night, only a constant, deep twilight broken by the occasional flash of a distant star. Timekeeping and navigation would be a monumental challenge, as there would be no sun to mark the passage of time. The temperature would be wildly fluctuating, but the planet would be able to generate heat from its own internal processes. The real mystery of these rogue planets is whether they could harbour life. Tapping into the planet's geothermal heat and possibly finding an underground ocean could provide the conditions for life to exist in a completely different way from what we see on Earth. It would be a lonely and isolated life, but it is a possibility that reminds us of the endless variety of the universe. The most bizarre planets are not those with strange compositions or unusual orbits, but those that challenge the very laws of physics. We have found planets that shouldn't exist, such as LHS 3154b, a massive world orbiting a tiny star. This discovery directly contradicts the core accretion theory, which explains how planets form from a stellar disk. It suggests that a new theory, such as gravitational instability, might be at play, where a planet can form from a rapid, all-at-once collapse of material. We have also found planets with metallic clouds, worlds where it rains titanium, and planets that are stretched into a football shape by the gravity of their star. These discoveries are not just interesting tidbits. They are pieces of a cosmic puzzle that are forcing us to rewrite our textbooks and rethink our place in the universe. The more we learn, the more we realize that our own solar system is a unique and special place, and that the universe is far stranger and more wonderful than we could have ever imagined. The most profound discoveries are often the ones that make us question our own planet and its unique properties. For billions of years, Earth has been a self-regulating system with a delicate balance of life, atmosphere, and geology. This collective intelligence of the planet's biosphere is a complex and beautiful thing, with all living creatures, from microbes to plants and animals, working together to maintain a stable environment. We as humans are now a part of this system, but our role is still in its infancy. We are in a stage called the immature technosphere, where our technology often harms the planet rather than helps it. But there is hope. The goal is to evolve into a mature technosphere, where our technology works in harmony with the planet's natural systems, a state where humanity's actions are a part of the planet's collective intelligence. This is the ultimate challenge for our species, to learn to be a part of the planet's nervous system and to ensure its survival for generations to come. The universe is full of wonders that challenge our imagination, but the most bizarre of them all may be a fluffy, low-density world with an atmosphere of silicate sand. This is the reality of WASP 107b, a super-Neptune exoplanet located 208 light-years away. This planet's fluffiness is a result of its low density, which allows light from its star to penetrate deep into its atmosphere. This light, in turn, creates a chemical reaction that produces sulfur dioxide, a gas that smells like matches. But the most incredible thing about WASP 107b is its clouds, which are made of fine silicate particles, essentially sand. These sand castles in the sky form in the planet's hot atmosphere, where sand particles condense, fall as rain, and then vaporize again in the hot layers below. This creates a unique weather system, a cycle of sand and vapor that is unlike anything we have ever seen. The planet also has a comet-like tail of helium, which is slowly being stripped away by the intense radiation of its star. The existence of planets that defy our understanding of planetary formation is a recurring theme in our cosmic journey. We have found planets that are too massive for their small stars, and planets that have survived the death of their stars. These impossible worlds are not just anomalies, they are profound challenges to our understanding of the universe. They suggest that our theories of core accretion and gravitational instability may be incomplete, and that there are still many secrets hidden in the stellar nurseries of our galaxy. The more we learn about these strange worlds, the more we realize that our own solar system is a unique and special place. Earth's delicate balance of gravity, atmosphere, and liquid water is a rarity in a universe of extremes. We began this journey by looking at the strangest planets in the universe, and we end it by looking at the most familiar one of all. Our home, Earth, is a living planet, a self-regulating system that has been evolving for billions of years. The delicate balance of our biosphere, the collective intelligence of all life, is a testament to the power of nature. But we are now a part of this system, and our actions have a profound impact on its future. The ultimate challenge for our species is to learn to live in harmony with our planet, to become a part of its collective intelligence, and to ensure its survival for generations to come. The strangest thing in the universe may not be a distant exoplanet, but our own existence on this tiny blue dot, and our ability to ponder our place in the cosmos. Let us now imagine a world where the scales of our solar system are completely different. Picture a scenario in which every planet, from mighty Jupiter to tiny Mercury, was the size of Earth. This grand thought experiment allows us to see how a planet's size is a fundamental part of its identity and function within our cosmic neighborhood. Mercury, in this new reality, would be a very different place. Its increased mass would give it a stronger gravitational pull, leading to a thicker atmosphere and intense internal heating. This would transform the planet into a volatile volcanic furnace, a new Venus 2.0. Our actual neighbor Venus would be largely unchanged, as its size is already very close to Earth's. It would remain a hostile, acid-clouded world with surface temperatures hot enough to melt lead. But for Mars, a larger size would be a profound blessing. Its increased mass would likely give it a stronger magnetic field and gravity, leading to a thicker, more stable atmosphere that could potentially hold liquid water on its surface. This new Mars would be a habitable world, albeit a geologically active one with frequent volcanic eruptions. The fate of the outer planets in this scenario would be far more dramatic. Jupiter, our solar system's colossal protector, would be a shadow of its former self. Its reduced gravity would no longer be strong enough to deflect the thousands of asteroids and comets that currently pose no threat to the inner planets. This would leave Earth and its neighbors vulnerable to a barrage of cosmic impacts. Saturn, the majestic ringed giant, would also suffer a terrible fate. Its iconic rings of ice and rock would be pulled into the planet by the new gravitational force, causing them to either fall onto its surface or be scattered into space. The ice giants, Uranus and Neptune, would also be fundamentally altered, likely becoming rocky planets with much thinner atmospheres and different climates. This thought experiment shows us that the planets in our solar system are not just random objects, but a part of a delicately balanced cosmic ecosystem. The existence of Jupiter as a massive gas giant is not just a scientific curiosity, it is a crucial component of our own planet's survival. This hypothetical transformation of our solar system also allows us to envision a cosmic physical challenge, a marathon across the planets. What would it feel like to run on these transformed worlds? On Mercury, with its lower gravity, you would feel incredibly light, your steps more like a series of graceful bounds. You could achieve impressive speeds, but your run would be a hazardous one, as you would have to contend with a surface scarred by ancient craters and an unforgiving, airless environment. On Mars, a place of rusty dust and low gravity, you would feel a strange sense of weightlessness, moving with a series of powerful leaping strides. The main challenge would be the constant threat of a dust storm, which can engulf the entire planet in a matter of hours. But on the gas giants, Jupiter and Saturn, your marathon would be a philosophical one. There is no solid ground, no surface to run on, only a continuous freefall through a stormy and chaotic atmosphere. This thought experiment shows us that a planet's gravity and atmosphere are not just scientific data points, they are the fundamental conditions that define our physical existence. The cosmos is full of worlds that seem to defy classification, and one of the most perplexing types is the so-called cotton candy planet. These worlds, like WASP 193b, are massive in size, but have an incredibly low density, making them feel light and airy despite their colossal scale. WASP 193b is a true oddity, a planet 50% more massive than Jupiter, yet its density is akin to that of cotton candy. This cosmic puffball challenges our fundamental understanding of planetary formation, as worlds so close to their parent star are expected to be stripped of their atmospheres. Scientists theorize that these planets are puffed up by the intense heat of their stars, causing their hydrogen and helium to expand dramatically. The Kepler 51 system hosts an entire family of these low-density worlds, and studying them provides us with crucial clues about how planets form and change over time. From the airy to the impossible, our journey continues with planets that simply should not exist. LHS 3154, a planet 13 times heavier than Earth, orbits a star that is 9 times smaller than our Sun. According to the dominant theory of planet formation, a star so small could not have had enough material in its stellar disk to form a planet of that size. The very existence of this world forces us to consider a new theory, one where planets can form from a rapid, all-at-once collapse of material in a stellar disk, a process called gravitational instability. Another forbidden world is Halley, a planet orbiting a red giant star that should have engulfed it long ago. This discovery challenges our understanding of how planets survive the death of their stars, and it opens up a new realm of possibilities for what can happen in the chaos of a dying solar system. The most bizarre planets often have the most extreme weather. Take Mascara 5b, an ultra-hot Jupiter, with a dayside temperature of 4,892 degrees Fahrenheit, hot enough to melt most metals. The night side is only slightly cooler, making it a fiery hellscape where life as we know it is impossible. Another scorching world is WASP 76b, where it literally rains iron. The dayside of this planet reaches temperatures of 4,300 degrees Fahrenheit, vaporizing iron, which is then blown to the cooler night side where it condenses and falls as liquid iron rain. The planet 55 Cancri was once thought to be a diamond world, a super-Earth with so much carbon that its interior was packed with diamonds. While more recent research has challenged this theory, it remains a testament to the incredible variety of planetary compositions. Finally, we have GJ 1214b, a water world with exotic forms of water that defy our understanding of physics. These bizarre worlds are not just scientific curiosities, they are puzzles that are forcing us to rethink our place in a universe far stranger and more wonderful than we could have ever imagined. We have seen the strange and the beautiful, the impossible and the bizarre, but our journey is not yet over. The ultimate question facing humanity is not what alien worlds we can find, but what worlds we can make our own. The dream of terraforming other planets, of transforming lifeless rock into a home for humanity, is a grand aspiration that forces us to look inward at our own ingenuity. The most promising candidate in our solar system is Mars. To turn the red planet into a second Earth, we would first need to warm it. This could be achieved with colossal orbital mirrors designed to focus sunlight onto the planet's frozen poles and melt the carbon dioxide ice caps. This would release greenhouse gases into the atmosphere, which would begin a feedback loop, gradually warming the planet and allowing liquid water to flow. The new Martian environment would still be a challenging one. Its lower gravity would require us to develop new technologies and even alter our own biology to cope with the physical strain. New species of plants, genetically engineered to thrive in the thinner air and different soil composition, would need to be introduced to create a self-sustaining ecosystem. The process would be slow, spanning centuries, but the reward would be a new frontier for humanity. Beyond Mars, the solar system offers other intriguing, if not more difficult, candidates for human settlement. Titan, Saturn's largest moon, is a world with a thick atmosphere and an abundance of resources. Its surface is a landscape of mountains and riverbeds carved by liquid methane, and its atmosphere is a rich mixture of nitrogen and hydrocarbons. These resources could be used as building blocks for a new civilization, providing us with all the raw materials we would need to build cities and power a new society. However, the biggest challenge of living on Titan would be its extreme cold and low gravity, which is only 1/7 that of Earth. A long-term presence on this moon would require us to develop new technologies to keep us warm and new physical adaptations to keep us strong. We could also look to the moons of Jupiter. Callisto, one of Jupiter's largest moons, is located far enough away from the gas giant's intense radiation belts that it could be a safe haven for human colonists. It is an icy world with a suspected subsurface ocean, and its resources could provide us with a long-term foothold in the outer solar system. The journey to these worlds is not a simple one, and the challenges are immense, but the prospect of a new home for humanity is a powerful motivator. The real wonder of these distant worlds is not their strangeness, but their potential to become a part of our future. This final section will bring us back to the most immediate of challenges. The universe is a place of extremes, but our own bodies are built for the delicate balance of Earth. What would it truly feel like to embark on a cosmic physical challenge, to try to run on the planets of our solar system, on the frigid, airless surface of Mercury? With a gravity of just 38% of Earth's, you would feel a strange mix of freedom and vulnerability. You would move with a graceful, bouncing gait, but your run would be a race against the sun's scorching heat and the planet's jagged, crater-filled landscape. A run on Venus would be an exercise in endurance and survival, with its crushing atmospheric pressure and a temperature that would vaporize you instantly. Your only option would be to run in a highly specialized armored suit that could withstand the incredible conditions. The sensation of running through the dense, suffocating atmosphere would be like running underwater, a constant struggle against an invisible force. A run on Mars, the red planet, would feel strangely liberating. With a gravity of only 38% of Earth's, your steps would feel like giant bounds, and you could leap over large rocks and canyons with ease. But you would have to contend with a fine, rusty dust that would get into everything, and the constant threat of a massive dust storm that can obscure the sky for weeks at a time. The outer solar system presents a different kind of challenge. On Jupiter and Saturn, there is no solid surface to run on, only a continuous freefall through a stormy and chaotic atmosphere. These worlds are a reminder that the physical laws of the universe are not always compatible with our biology. The search for a new home for humanity is a profound quest, and every discovery we make, from a bizarre exoplanet to a new way to adapt our own bodies, is a step toward a future where we are not just inhabitants of one planet, but citizens of the cosmos. The vastness of space has always invited us to look outward, to search for a second home, and to ponder the existence of life beyond Earth. Our journey has taken us to the bizarre, to planets of fire and ice, but our most profound quest now leads us closer to home. Within our own solar system, in the deep reaches of space, lie worlds that may hold the key to answering the ultimate question: are we alone? These are not planets, but moons, each with a unique possibility of harboring life beneath their frozen surfaces. The most promising of these worlds is Europa, a moon of Jupiter. Europa is a celestial body of staggering beauty, its surface a fractured and crisscrossed shell of ice. But beneath that icy crust, scientists believe there lies a vast global ocean of liquid water. This ocean is thought to be warmed by tidal forces from Jupiter, creating a dynamic and potentially life-sustaining environment. The cracks and ridges on Europa's surface are not random. They are a sign of geological activity, with new ice forming and old ice being recycled. This constant motion, and the evidence of water plumes erupting from the surface, suggests that Europa's ocean is in contact with a rocky seafloor, a crucial ingredient for life as we know it. The search for life on Europa is a top priority, and missions are being planned to send probes to explore its ocean, a journey that would involve drilling through miles of ice to reach a world of complete darkness, pressure, and the unknown. Another captivating world in our own cosmic backyard is Enceladus, a moon of Saturn. Enceladus is a small, icy moon, but it has one of the most remarkable features in the solar system: geysers of water vapor and ice particles erupting from its south pole. These plumes are a clear sign of an active subsurface ocean, and they have provided scientists with a way to sample the ocean's composition without even landing on the moon's surface. The plumes contain not only water, but also salts and complex organic molecules, the very building blocks of life. The heat required to keep this ocean liquid is believed to come from tidal forces from Saturn, a powerful force that squeezes and stretches the moon, creating friction and heat. The search for life on Enceladus is a major focus for future missions, with probes being designed to fly through the plumes and analyze their contents, a journey that could provide us with the first definitive proof of extraterrestrial life. The hunt for life in the solar system is not just about these moons. We are also looking at Titan, Saturn's largest moon, a world that is not a water world but a world of liquid methane. Titan's surface is a landscape of mountains, dunes, and lakes. But these lakes are filled with liquid methane and ethane, not water. Its atmosphere is a thick, nitrogen-rich haze, and it is the only other world in the solar system with stable bodies of liquid on its surface. The possibility of life on Titan is a fascinating one, as life could have evolved in a completely different way, using methane as a solvent instead of water. The search for life on Titan is a long-term goal, with missions being planned to send probes to explore its lakes and search for any signs of a unique form of life. The existence of these moons in our own solar system, each with its own unique possibility of harboring life, is a powerful reminder that the search for extraterrestrial life may not take us to distant galaxies, but to our own backyard. It reminds us that the universe is not just filled with strange and exotic planets, but with nurturing ones that could and may be teeming with life. The journey of discovery is just beginning, and with every new mission we are taking one step closer to answering the ultimate question. The greatest mystery in the universe may not be a distant planet, but a moon orbiting a gas giant, and our ability to ponder our place in the cosmos. The final act of our cosmic journey brings us to the ultimate question. In a universe of 100 billion galaxies, each with 100 billion stars, What is the probability that we are the only ones? The strange worlds we have found, from the diamond planet to the water worlds, are a testament to the incredible variety of the cosmos. The universe is far stranger and more wonderful than we could have ever imagined. The journey of discovery is just beginning, and with every new telescope and every new probe, we are taking one step closer to answering the ultimate question. The greatest mystery in the universe may not be a distant planet, but our own existence on this tiny blue dot, and our ability to ponder our place in the cosmos.